Hello, in this video we're going to be talking about the chloroplast. So let's not waste any of your time. Let's get right to it. Now when we're talking the chloroplast, we want to remember that that's the location for photosynthesis. Okay, and you can see this is the image there. That's not a chloroplast. Hopefully you can recognize that. But that is a layer of a leaf. It's a cross section. The very top is the upper epidermis. That's the part that you would see if you were looking at a leaf. The lower part is the lower epidermis. That's the bottom half, the bottom side. If you flip it over, you would see that. But what we want to think about is that mesophyll section there in the middle of the gray area with the big bracket there. That's the location of the chloroplast within a leaf. The chloroplast, super important location for photosynthesis. It's a double membrane, just like the mitochondria had outer membranes, inner membranes. Photosynthesis is the same way. And that inner membrane is especially the thylakoid membrane. That's going to be where the photosynthesis, the LDR, the light dependent reaction occurs. Super important. Okay. Now this is a picture of a chloroplast, the little green peel. And just some things that we want to make sure that we see or recognize. First and foremost, to talk about the thylakoid. Those little flattened stacks, those little just basically disc-shaped objects. And now the whole process of photosynthesis occurs inside of the chloroplast. Unlike cellular respiration, which began outside of the mitochondria and worked its way inside, everything happens inside of the chloroplast. But you got those flattened disc-shaped objects, the thylakoids, and of course they're stacked, and they're also connected to each other. So it's like one big compartment, one big group of objects working hard to absorb that light energy with the chlorophyll that's inside of the thylakoid. It traps that light energy inside of it. And if you want a mental thought about what that looks like or what that is similar to, you can think about your car in the summertime with the windows rolled up. You park it and it's in the sunshine, go inside and you come back out and it's really hot inside your car, much hotter than it is outside. And this can happen even in the wintertime. If you got a bright sunny day in the wintertime, you can get in your car if it's been parked outside, even though it's maybe cold, 30 degrees, 40 degrees, but inside your car is really warm because that light energy is able to go through your glass, got lots of energy, and it gets trapped in there. Warming up your car. The light energy inside the chlorophyll is similar. It traps it in there. But the amazing part of all this, as I've already mentioned a couple of times, the ability to convert that light energy, okay, into chemical energy, which then gets converted into food, a sugar molecule. Super important. Two other words we want to talk about and make sure that you grasp is that if we're talking about one stack of those thylakoids, that's a granum. Okay, one stack, granum. If we're talking about all of the stacks of thylakoids, as in the one big compartment, that's a grana. So granum, one, grana, all of them. Okay, continuing to think about the chloroplast. We talked about the thylakoids, and it's the membrane of the thylakoids where the light-dependent reaction is going to occur, and we'll see plenty of pictures about that. The second part of photosynthesis, the Calvin cycle, that occurs in the stroma, which is as semi-liquid as you can see there, much like cytoplasm material, jelly-like. When we talked about cytoplasm, we referred to, think jelly. It's a lot of liquidy, it's kind of solidy, somewhere in there. But not only does it house the Calvin cycle, it also contains some things that help with that. It contains some ribosomes, so if it's got ribosomes, you know it's making some proteins. It's got some the enzymes that are needed for the Calvin cycle are there as well. And of course, if you're going to need energy to do this, so it's got some starch in there as well that can be broken down and used for all this. So if you think about it, within the chloroplast, which is making the sugars, you've got starches being broken down. Maybe broken down is not the right word, but starch that is used to for the energy needed to get all this stuff done. Well, that's our video on the chloroplast. When we come back together next time, we're going to be talking about the kind of an overview of photosynthesis. So we'll see you then.